Hey, this is Mike with TVE. Thanks for coming back. And today we are going to do a few things. The first thing we want to do is the panel safety inspection. We've done it before at the Cube at our stage, but now we're inside a home, real life situation here, real life panel. You know, as you can tell right away, there's an issue with the not being able to open a door. That's why, you know, you want 30 inches of clearance in front of your panel so that, you know, it gives you that working room to be able to work in this panel safely. Right now, I'm not going to, you know, take this apart. We're going to continue on with our inspection, and then in the end, we're going to clean it all up and make it up to code. First thing I want to do is I'm going to remove these tiles, and so I can get a good look above here. I'll put my trusty mask on. There is it's like a fiberglass tile, so it can get pretty nasty. So I just want to remove that. Yes. Okay, so now we got this alarm DC outlet here. It's not plugged in. They're not using it. It's just kind of draped over here. So we're just going to get rid of this. You know, I'm not really that tall, but we are in a low ceiling, so it may look like I'm a giant, but I'm medium size. Okay, the panel. We will begin taking off the panel screw. You can see here, they've got a regular outlet attached to the panel. That needs to be a GFCI, ground fault circuit interrupter. I've done a few videos about ground fault circuit interrupters. You need that protection here at the panel. Depending on the jurisdiction you're in and the county codes, where I'm from, you also need a hardwired combo smoke detector right above your panel. So that is not here as well. One thing you want to look for when taking off the panel cover is, are the screws blunted? Are they blunted, meaning, you know, there's non-point. If there's a point in there, you've got a chance of hitting a wire when you screw it in. Now that I've got the fiberglass tiles off, I can take this mask off. But you want this blunted so that when you screw it in, it doesn't poke a wire and cause a short. All right, so now we got the panel screws off. We're going to carefully remove the panel, set it aside. Next thing you want to see is, I didn't even check this because I couldn't open the door, is the panel labeled. You can see this one is not. So by the end of this, we will have a labeled panel. Well, they got the furnace breaker labeled, so that's pertinent. And then this is what we got in here.
No! God, please, no! No! No!
So, a couple of things just right off the bat. Any unused conductors in the panel, they need to be removed from the panel. They have abandoned this circuit. So we will remove this from the panel, take it out completely. Now, they've got, let's see, you know, it looks like there's a combination of aluminum and copper wiring. I believe I even see some knob, and there's also, they've even got knob and tube in here. I don't know, maybe I can point my flashlight on here to see it better. And actually, let's see, we're gonna investigate what that is. It's clamped on with, to that ground wire there, so I want to check what that is, but they've got like single strand wire in here. They got a whole bunch of different types of wiring here.
This is Houston. Say again, please.
Houston, we have a problem.
You know, a lot of it is this kind of old cloth wire. Kind of breaks and is real brittle. The breaker, the breakers are, this one has a dead short. I've already tested this. This goes out to an outside shed, and when you turn it on, it barks at you a little bit. So there's a short in the ground. They used regular Romex and just buried it instead of UF cable. So we're going to leave this off for now. You want to make sure that, you know, oh, here's the knob and tube over here. I don't know if you can get this. See these two things right here? Those two looking guys there. There's actually just a small single strand conductor coming from it. If I pull on it, you can see this is one of them. And then the other one is right next to it. We have a company policy. We do not work on knob and tube. What we do is we remove it completely and then rewire the circuit. You know, knob and tube itself, you know, it may be in a house for 100 years and work just fine. You know, and that's not the problem. The problem is that, you know, there's probably been 10 or 12 DIYers or electricians that have tapped into knob and tube really hard unless you have the proper electrical tools to figure out what's the hot and what's the neutral. So, you know, and we don't know where people have tapped into it, where the splices are. And you can just see from this kind of basement here that there's a lot of junction boxes and a lot of wires that are just, you know, outside of boxes, no cover plates, and just kind of all strung together. So I will not repair this. What we're going to do is we are going to rewire all of this. The bus bars, the ground and the neutral bars, they look good. You want to make sure that there's no double taps. You know, you are allowed to have two grounds under the same screw if they are the same size. You are not allowed to have two neutrals under the same lug, even if they're the same size. And it does appear that each neutral has its own lug. So that is good there. You know, and then the next thing, of course, you want to make sure is, are the circuits fused correctly? So this is a 12 amp, you know, number 12 wire, which is rated for 20 amps. That's good. So we're going to go down the line here and make sure that they're all rated as such. Okay, so I'm going to go ahead and take a moment to, I'm going to remove this wire. I'm going to pull some of this out so I can get a good look at all the conductors, and we'll be right back with that. Here, which has got a ground in it, and then I've got cloth wiring here, which is completely void of a ground wire. So I'm just stripping this all back so I have more room to play in this panel, sort it all out, and kind of organize these wires a little bit. Okay, well, we got one half of the panel cleaned up here. So we're dealing with knob and tube, grounded cloth, ungrounded cloth, and there's a little bit of Romex in there. Actually, the only Romex really is this service entrance cable here. It is copper conductor, so that's good. But yeah, this side we cleaned it all up. You know, there's only so much I can do here with this knob and tube. I don't want it to brittle and break. And then just shorting, you know, clipping off the extra conductors that were in there, stripping off all of the extra sheathing. It looks a lot cleaner over here. I still got this side to do. So I will continue, give me a little bit, and by the time you get back, this whole panel will be cleaned up, and then we can start adding circuits and working on it. Okay guys, we're back, and the panel's finished. We did a complete panel cleanup. Got rid of the majority of the code violations here, 90-degree turns. It's all nice and clean. Now I feel comfortable playing in this panel, adding circuits to this panel. You could see, I mean, look at all this tender that was in there. I mean, this was just an arc and a spark away from a disaster. All this extra wire was hard to maneuver in here, and now it's ready to do what we want to do next. We are going to run two 30-amp circuits, one dedicated circuit for an RV, and the other dedicated circuit is for a dryer. So if this is something you're thinking about doing to your house, you know, stay tuned, and we'll get those videos out next. Okay, we're gonna start drilling our holes for the dedicated circuits. So just wanna make sure that there's no wire on the other side of these beams here, these trusses that we're gonna drill through and hit. We've got our holes ran through the trusses. And so what we're gonna do is just, again, I'm not a giant, this is just a really short ceiling. I've always wanted to be able to rough a house, not using a ladder, but let's see if I can get it right in that hole. Come on now, come on, look at that. A lot of practice there, boys. Okay. Okay, guys. The next step is we are going to install the cut-in box, a 2-gang box. I like to use a 2-gang box when we are dealing with 240 volt circuits. This is the actual plug I'm going to be using here. And it kind of screws on like that, so you know the 2-gang box is perfect. I can have plenty of room in the box to make up my device. And really, these cut-in boxes or remodel boxes, whatever you call them in your area, you get it where you want. Obviously, you don't want to do it in between two of these, and these things are real hard to cut. This type of siding, so you just want to be real gentle. There's a few ways you can do it. You want to trace your box out, okay, and don't trace down here where your box will just fall through. You want to trace up in between the tabs, and then it give you a nice guide there. So you may be asking, how did I come up with this spot? How do I know this is where my wire is going to come out? Well, when I was running my wires through the trusses, I got all my wire to the edge, and then there's a 2x12 that's right here. And I know this because I could see the concrete from the inside. And then there's a 2x12, and I want to be above that, so I'm not cutting my 2-gang box and a 2x12. That, me and Tim would be out here for a couple hours trying to do that. So I go above it, and so when I cut my hole, I can then drill down through the bottom plate, and then when I drill down through the bottom plate, my wire will come right inside that 2x12, and I just fish it up, and then I grab my wire and put my box in. So how do you know like where the concrete ends and where does the 2x12 begin? Well, I mean, I've been doing this enough where I know. I mean, it's right here. You can see the bump out, of the siding here, and that bump out is usually that transition. So some people will drill a small pilot hole. I think I even said on the video, we'll drill a small pilot hole to figure out where we are outside. I didn't do that because I know where we're at. But if you do that, just get a very tiny bit, just a pilot bit, just so you can, get a reference point, and then you can mark your box. So we have our box marked out, and we are going to go ahead and cut this bad boy. Okay, so now I've got my drill bit in here. What we do is I like to run it through the ears at least once. You can do it a couple times, and that way now when you try to drill it in, it'll go through smoothly. especially if you've got plastic ears. The metal ones aren't as bad, but the plastic ears, you will strip them 100% of the time if you do not do this. All right, so now really it's just a matter of putting this box in. Slip the wire through the hole. So now you just screw in the ears. And sometimes when it's real thick, if you got a stud right here, you can drill a screw down it too, just to make sure it's doubly secure. And I think that's what I'm gonna do. There we go. Where's that box going? Nowhere. Next step is we are going to, I'm here, the wire's here. So, the next thing we're gonna do is strip the wire, make up the plug. Again, use wire strippers for this. I told you I typically only use 3 tools. My dikes being one of my favorite tools to use. So once you got the wire stripper, typically you got your hot, your neutral, your ground. This is a 240 volt circuit though. This will be used as a hot wire, phase A, phase B. Okay, so now we'll hook up the RV plug here. This is a NEMA TT-30R. It tells you on the back how to hook it up, green, white, and then black, of course, right here. So it's really just color to color. You just follow the instructions. You don't need all this. You want 6 inches in the box. That's code, at least 6 inches here. And then you want to strip the ends out. Again, you don't need 1.5 inches of copper. In fact, you want as little copper showing as possible. Nothing to do about the ground wire there. Ground, neutral, and hot. It's a great way. It's just good to get in practice to doing things that way. If you hook up something and you're wiring something hot, and you hook up it hot, neutral, ground, you hook up the hot wire and there's a load on there, and you get in between the neutral wire as you're hooking that up, it's gonna hurt a little bit. Okay, well, good. You can pull on it, you can make sure it's in there good. Now it's just a matter of tucking the wires into the box and then screwing the device. So we're gonna go ahead, it's outside, so we want to protect it from the elements. So we got a weatherproof in-use cover, so we'll put this on and the cord can go up here, and this can remain closed, and even if it's raining, there's no danger of getting shocked because this is protecting everything. So these bubble covers are great. They they come with about, 11 different configurations you can use. You've got, it's a 2-gang cover, so, you've got all these options here. Receptacle, Decora style switch. The Decora style receptacle or switch looks like a rectangle. It is, this is a regular outlet. This is a Decora style outlet. GFIs fit in there. Decora switch will fit in there. So if these are outdoor switches, what we're hunting for is this giant circle here. So we are going to measure that, cut it out, fit that over there. All right, so installing a bubble cover. I've done this video before with a single gang bubble cover. We might as well capture doing it with a 2-gang bubble cover. They're still a pain to install. You've got to back out the screws. First, make sure it's right side up. That would help. And then you want the screws out far enough so you see how they slide into these tabs here. So I actually want to get them a little more out, because now I've also got to put the insert in. So now they're out. This insert here it's got to fit underneath the screws here. With a 2-gang, it's a little bit tricky and sometimes can be a real headache getting these to snap in, but you know, we got lucky this time. Fairly simple. And now you can tighten up your screws and make this a real snug connection. There we go. See the weather stripping on the side to prevent the water from getting in. You want to make sure it's nice and tight in there. Okay. Okay, welcome back to TVE. We got the outside RV receptacle in there. Now we're gonna finish it up by installing the wire in the panel. Here's all my excess that we rolled out earlier. So you just wanna leave enough to where you can pretty much get to the bottom of the panel in case you have to make any bends in there. So you just cut it. Now that you've cut it, we already have a connector in there from a circuit that we pulled out when we were doing the panel cleanup. So I don't need, normally you'd need to install a Romex connector. I'm just going to use what's there now. And we're gonna reroute it right here. And we are going to get it in the panel. Now that it's in, you want to secure it in the panel. First, before we secure it, I'm going to secure it by stapling it to this floor joist over here. But first, I'll go ahead and cut the jacket and install the breaker. So, stay tuned. So welcome back. We got our dedicated circuit for the RV. Turns out it was just a 120, a 30 amp 120, not a 2-pole 240. So we've got it plugged in, hooked up, nice weatherproof cover there, and the RV AC is humming. So good to go.